Hello friends, myself Gururaj from VTU College of Engineering, Mysuru. I'm here to explain the Computer Network Laboratory tutorial which is prescribed by Visvesvaraya Technological University, Belgaum. Out of this, fifth one and sixth one are the new concepts which they had included in the syllabus. The question will be like implement and study the performance of GSM on NS2 or NS3 platform. As the question tells us that GSM network stands for Global System for Mobile Communication. This belongs to 2G technology, where we are implementing GSM technology in 2G networks. For our simulation study, we had taken the environment of NS2 itself, where NS2 will completely support wired networks and wireless networks, but it will also support semi-wireless networks, but not completely, partially. The animation file which is there in NS3, that is built only for wired and wireless network. Even though the modules of LTE, modules of UMTS, modules of GPRS, modules of GSM are already present in NS2, but animation file we cannot able to weave with the help of NS2 simulation tool. So what we're doing is, as the question tells, implement and study the performance. We are just creating the environment of 2G technology with the help of this topology shown here. I am considering the five nodes in our topology. The first node is called as the sender node, and the last node is called as destination node. You can assume this as one mobile device, and this also as another mobile device. If this mobile device wants to communicate with this mobile device, it has to go with its BTS, that is base transceiver station. And if it is very near, the next neighbor is the respect to destination BTS that will communicate directly with the help of destination BTS, and it reaches its destination. If the destination is very far from the sender node, then the sender node has to communicate with its BTS, and BTS has to went through number of hops in between. That depends upon the distance, that depend upon the BTS locality, and at last it reaches the BTS of the destination and reaches the actual mobile destination. Okay, this is a simulation topology what we had considered for the simulation environment. And the program will be like this. As we are much aware of wide networks and wireless networks of NS2, those networks will generate common data trace file. All the data trace file will be having an extension of file name .tr, but this 2G network and 3G network will generate web trace file. The only reason is that if you want to execute 2G technology, or if you want to include 2G technology or 3G technology, all those has to work with the help of application layer protocols, HTTP and all. And if you want to work with 2G and 3G, that will directly connect with the internet, so it will generate web trace files. So the path what we are executing for the previous programs like wired and wireless network will be not same for these two couple of programs. So what we are doing is we have to go with a different path of execution. You have to go with you can go with any Linux operating system. There we have to go with the respective path like this. We have to go with NS, it may be if the software is present on the desktop, cd space desktop. Within that we have NS all in one, 2 point, NS all in one, 2 point, any version it may be. Let me consider it as 35 slash NS 2.35 slash TCL we have within that. After that we have within that we have ex called as example folder. Within that we have a wireless scripts example folder, SCRIPTS. Within that, if you press enter here in the terminal of your Linux environment where it is already get installed with NS2 software, we will get a set of files within this folder. Out of those files, the very important file which is present in this set of folder is which within this folder is called as web.tcl. Why we require that web.tcl? Why? Because the program of 2G network and The program of 2G network and 3G network will execute with the help of web.tcl, which is present in your wireless scripts folder. For the 2G network and 3G network, why we'll call this sort of networks as semi-wireless networks? Because even though the mobile devices move from one place to some other place, I mean the mobility is the main feature for mobile networks, but BTS cannot be moved from one place to some other place. I mean to call it as a network, so we'll call it as network or sometimes tower and all. That BTS cannot be replaced from one place to some other place. Hence, it is a combination of completely mobile network and fixed topology. Hence, this sort of network we can call them as semi-wireless network. In this program, we have the first parameter is called as general parameter. We are setting the stop time as 100. We need to finish this complete program simulation by 100 second. And the topology type is GSM here. The type of topology what we are considering is the type of network what we are considering is GSM. AQM parameters is very important for GSM called as active queue management. For this, we are considering minimum threshold value, maximum threshold value, and adaptive value. If the value of adaptive is 1, we have considering adaptive RED. If it is 0, we are going to consider it as plain RED. What is the meaning of RED? Random early detection. It is one of the queuing methodology. The traffic generation parameters, what we had considered is three variables we are declaring here. Flows is equal to 0, windows as 30 size, and web is equal to 2. That is, it will generate two web trace files. Let me explain in greater details of web trace files later. As I told very precisely that this NS2 will not support completely GSM network or the 3G network. We are going to by default plot the graph by taking all the parameters of the GSM network and CDMA network. In this, we are taking variable names like wrap, that is wrapping the wrap plots, and source trace and destination trace, which is required to plot the graph. I'm assigning the value is to this variable and bs2 to this variable. Let me explain these all variables in greater details in the further parts. The main important bandwidth requirement for 2G network is we have uplink bandwidth, downlink bandwidth, and uplink propagation delay and downlink propagation delay. If you want to download any image from the internet with respect to 2G network, it will take a lot of time. The propagation delay will be high, and the bandwidth required is also very less. So that we can depict with the help of this number of values, 9600 bits per second for downlink and uplink as parameters, and propagation delay as 0.500 seconds for the downlink and uplink. As I told very many times that this NS2 we can just provide the environment of GSM or the CDMA network. We cannot able to go with the real-time implementation of this, as to perform all those things we need direct connection of the internet. Just we are simulating for the understanding of GSM network and 3G network or the CDMA network. We are starting with the simulator class, and we are creating the general trace file called as out.tr. This is what called as data trace file. Within that, we are going to create two other web trace files. Let me explain that later. In our topology, we are considering IS, the sender node, MS, the mobile station, that is intermediate node, BS1, the second base station, and BS1, the first base station, and BS2, the second base station, and LP, the last point, that is destination node. And we all know that if without creating a cell topology, no 2G network and 3G network, or it may be 4G network, or it may be 5G network never works. For creation of all these sort of networks, we need to start with cell topology. A cell topology is a one where we have a cell site with respect to its BTS and the mobile station. By keeping all these nodes what we had created, we are setting the links with the help of link setup for the cell topology by making NS and nodes as global. That is reference, as we all know that the link setup will have 7 parameters, reference to the class, that is for the simulator class, and type of link, the sender node, that is from LP, the last point, to the node called as BS1. And here with this topology, what I'm calling it as sender node as IS called as initial source, and the destination node as LP called as last point. And I had taken this variable name as BS2. You can take any variable We can take any variable name. We had taken this as a BS2 and this as BS1 and this as mobile station. Okay, for our topology. By keeping all those variable names, we are constructing the cell topology. That is, we are constructing cell topology by link setup. The duplex links between LP, the last point, and BS1, its base station, with this bandwidth and the simulation time. As I told many times that between this base station and this base station, I can have many number of hops. So for that simulation environment, we are taking 10 nodes of MS. That simulation time it may take, followed by the type of queue. The next link setup is reference to the simulation class, followed by the type of link, followed by BS1, followed by mobile station. That is between these two parts, mobile station and BS2, BS1 for between these two parts, BS1. Okay, and followed by mobile station with BS2 and with the bandwidth of 1 bps and 1 millisecond and the type of QS RAD, that is random early detection. And in the same way we had taken all the simulation steps for link setup and constructing the cell topology. I'm going to call the topology as GSM cell topology. As it is a put statement, it will print as we had embedded with the help of double quotes. Once the cell topology has been constructed, this link parameter has to be set up by taking all the variable names. Why? Because here within your this we have a switch statement here. This switch statement will take a value of type. What the type we had considered here? The type what we had considered is GSM. The GSM is the type. So it will take this as GSM type, and it will come here, and it will go with GSM cell topology, and it will go for it will come out of this switch statement. It will call this method. What is that method here? Set link para of type. Or the type we are taken here, GSM type. Okay, it is a called method. This is called as called method. Once this is called, the control will comes here. That is what the procedure name, set link para of a parameter. What is the parameter? What we had passed there, type as GSM. That will be assigned to T here. Okay, by when the when the procedure has been called, it consists of we are making all these variables as global, what we had defined before, and I'm assigning the bandwidth, that is reference to the simulator class. Bandwidth, that bandwidth I'm going to assign, we are going to assign between BS1 to mobile station with this amount of value. Why they are taken $BW? Because the content of this $BW DL, that BW DL, the prop DL, we had considered here. So BWDL of $T. What is the meaning of $T here? $T, what we consider is T here. The value of T is GSM. So that represents the value of GSM. Why? Because the what we are considered a parameter as GSM here. So it will take these values 9600 upon 500 and all here. Okay, and the type of link is duplex, as we already mentioned. That is, the bandwidth is going to assign between these two nodes of amount of this value, which is of type GSM, and the type of link is duplex. And at last, we are assigning the Q limit for the link parameters. The Q limit between BS1 and MS is 10 and BS2 to MS is 10. Okay. And once we done with all the link parameters, once all this has been called, we need to we need to go with the Q parameters, the different Q parameters. Q parameters has been already declared already. We are using those variables. We are assigning those variables here. Q is a class. Within that, we have a type of Q is RED. So what type of Q we are using? The type of Q is adaptive RED. Set adaptive underscore, a variable name. The value is 1 here. That is assigned to this variable. That indicates what type of RED I have to use here. Adaptive RED. In the same way, the minimum threshold value, maximum threshold value, and window value will be assigned to all these variables to the further operation of your GSM network. And we are assigning, we are creating two very important objects called as insert delayer objects. This object is going to create within a class called as delayer class. With the help of an operator called as new operator, this object is going to create between mobile station and BS1 and mobile station and BS2. That is in between these two things. That is mobile station and BS1, mobile station and BS2. For this, we are setting the insert delayer, the delay between these two nodes. And after that, we are calling we have a statement called as if statement. If flows, the value of flows is equal to 0. the value of flows is equal to 0 here. The value of flows what were declared initially is equal to 0 here. The condition satisfies. So this set of statements will be executed. Here, please remember the complete path what we had considered for the GSM topology is only one path from the sender to the actual destination. Only one path we have. But the complete path we are going to divide into two respective paths. One is the sender to first BTS and BTS to the destination. This is the first path and this is the second path. But actually, we had taken completely as one path from the sender to the destination node. And after this, as this is only one path, so the flows is equal to 0, it will match as a condition, it will come here, and it will assign, it will going to create a TCP object, TCP1, this creation of the object between IS and LP. What is the meaning of IS? The sender node. What is the meaning of LP? The destination node. And the flow ID is 0. What type of TCP we are using? Is SAC, that is selective acknowledgement. Okay, and I'm assigning I'm creating the object between IS and LP here. And one more point, if you would have taken TCP as a protocol of the transport layer, we have to consider the FTP as a protocol of the application layer. So we are attaching that application to your TCP1, and I'm calling the complete TCP protocol and the traffic generation with at this moment, that is 0.8 second. Okay, and if the flow is greater than 0, if the flow has been divided into two respective paths, what we have to do, we have to create two objects, one for the sender and one set of the TCP generation for the sender and the second set of TCP generation for the destination. That is TCP1 between IS node and LP with a 0 and TCP2 with one sender and destination with the flow ID as a 0. And what is the meaning of TCP sync? The destination node. And we are assigning the window value what we taken for the simulation. The window value what we assigned is 100 here. The window value what we had assigned here is what we had taken a window value here that we are assigning to this value. That value we are using here. So we can change the value. We can retain the same value also. We can change whatever the value we want. Okay, and the same way we are assigning the set of values to windows, and we are calling the simulation of these flows at 1.0 second with FTP2, and I'm stopping the simulation at 8.0 at FTP2. And at last we are calling the procedure called as stop at which second the stop has been called at 100 second. As we have taken the simulation stop time as 100 here, at that moment the simulation stop has been called, and we are taking all the variables as global, and as we have taken a wrap value as 100, that wrap value is assigned to a variable called as wrap, and sender ID, the complete trace file of sender to sender ID, the complete trace file of destination to DID, and the output trace file to a variable. By keeping wrap, SID, DID and a, we are plotting the graph. To plot the default graph of web trace file, we require two important files. The first file is called as raw2xt and the second file is called as getrc. These two files are present within the desktop, within NS all-in-one, within NS 2.35. Within that we have bin folder, within that we have raw2xt, within that we have getrc. So we have three paths, dot dot slash dot dot slash dot dot slash. That is on the desktop we have NS all-in-one, within that we have NS 2.35, within that we have bin, within that we have getrc. We have to use these contents of the paths to perform the we have to use these paths contents to the file contents to plot the graph. So we cannot call the paths always, so we are assigning this path to two variables. One is getrc and the second one called as raw2xt. And if you want to use this content, we can directly go with getrc, $getrc and $raw2xt. Okay, and we are executing the path which is we are executing the content of this with the help of exec command, exec followed by $getrc, minus the stand for the sender option, sender id, destination id, and the flow is 0. And we are assigning a variable called as out.tr. As we had taken awk script in case of the previous programs, we are taking getrc and raw2xt for your this web trace file program. And by this pipeline and slash, this indicates two symbols indicates this execute command not only applicable to this line, this will be also applicable to the next line, that is continued. This exec command will also work for This exec command will also applicable to the next line. As we had executed here with the help of getarc, we have to execute the auto-xt. These two commands will similarly behave like a awk script extracting tool. And we are pushing all the contents to a file name called as plot.xgr. XGR stands for extension of xgraph. We are pushing all the content to plot.xgr and we are giving this as an input for the xgraph command. So we're executing the exec, the graph name followed by the x-axis name followed by y-axis name followed by the name of the data, the web trace file name. If you plot this, we'll get a graph and that graph will be here, the throughput graph. As in the question, they clearly mentioned that study the performance of GSM. The performance can be calculated with the help, the examined with the help of that graph. And here we have taken a minus a stand for out.tr, as we have taken all the data to a. This is minus a is out.tr. S stand for sender, m for messages. We are wrapping all the messages. The value of wrap what we have taken is 100. It will go up to 100 plots, 100 values in the plot graph. Okay, plotting statistics. It's a plotting statistics. Okay, and after calling the stop procedure, it will deallocate the memory, and at last we are going with $ns run. It will execute the complete program. As we should have executed, we'll get a graph like this, and out of this we have packets and acknowledgements here, and packets we had considered, and we have to consider the acknowledgements. And this we have a certain number of gaps here that indicates the packet has been lost. In case of 2G network, the data transmission will be not so continuous as we have the available bandwidth is less and the propagation delay is high. As we have taken TCP protocol for 2G network or GSM network, we have an acknowledgement, and acknowledgement will also be not proper. Okay, this is what about here GSM network. And for the GSM network, we have a trace file will look like this. Okay, and in a similar way, we are going with CDMA topology. CDMA stands for code division multiple access, and this will be applicable for 2.5G network or 2.7G network, and somewhat for the 3G network. 3G network follows the principles of WCDMA. The topology and all retains the same for this exercise program also. The only thing is we have to change the bandwidth of uplink and downlink and propagation delay of uplink and downlink. Except this, everything is same. If you execute the same program, the complete program, will you get a graph like this. In this graph, what we have is the continuous send of data and continuous receive of acknowledgement. This indicates the 3G network having higher efficiency compared to 2G network, and this is what we had examined with the help of here simulation topology, where we have a higher bandwidth in case of 3G network and less bandwidth in case of 2G network, higher propagation delay in case of 2G network and less propagation delay in case of 3G network. And all this skip 1, skip 2 and all we should not consider. Why? Because we are plotting the graph by default, that raw2xt, and here the other file name called as raw2xt, and we have one more file name called as getarc. Those two files will generate those skip files. Okay, and for the same thing we are getting for here the CDMA trace file with respect to its bandwidth. Thank you. Thanks for listening. This is the end of network simulation programming.